This is the first of the problems that are at the end of the PowerPoint for 8.1. This first problem is looking to find a 95% confidence interval for the mean weight of newborn elephant calves. There's a sample of elephant calves have been weighed, and they've found that of this sample, the mean is 244 pounds and the standard deviation is 11 pounds. So from here, we can start this problem. In part A, we need to find X bar here, which is the sample mean. So that's been given to us of 244 pounds. Standard deviation, which equals 11 pounds. And N, which equals 50, as there were 50 elephants weighed, newborn elephants weighed in this sample. If we move on to part B, it's asking for the margin of error, or error-bound margin, as the text likes to write that, for the newborn elephant weight. If you remember, the formula for error-bound margin is equal to Z times standard deviation divided by the square root of N. For this one, we're looking for a 95% confidence interval, so we know that alpha equals 0.05. We can use either Google Sheets to calculate. If we need to find Z, we could use Google Sheets, or we could look at the confidence interval chart. And if you look at the 95% confidence interval right here, Z score for that is 1.96. So now we have all of the information necessary to figure out the error-bound margin. We can put G equals 1.96 times 11 divided by the square root of 50. If you calculate that out, you find that it equals 4.16 pounds. Part C is asking us to find the 95% confidence interval. 95% confidence interval. The formula for that would be the point estimate, which in this case is the sample mean, plus or minus the error-bound margin. So going back to here, 244 plus or minus 4.16. We can find that the confidence interval, this is the notation, is, usually use parentheses, 239.84, which is 244, subtract 4.16, and then the upper limit is 248.16. Part D asks us to explain what this confidence interval means. So if this is our confidence interval right here, that means we are 95% certain that the population mean which in this case is elephant weight, newborn elephant weight, sorry. Lies between 239.84 and 248.16 pounds. So we're 95% certain that the true average weight of newborn elephants is somewhere between those two values. And finally, the last question asks is what will happen to the confidence interval obtained if 500 newborn elephants are weighed instead of only 50? And why would that occur? So if we were to sample 500 elephants instead of 50, we would be increasing the sample size, and that means that the confidence interval would decrease, which means we're more accurate with our estimate of this population mean. So we can estimate more accurately and the confidence interval will decrease. In example 2, the U.S. Census Bureau would like to know how long it takes people to fill out the census form. So they've conducted a survey of 200 people and averaged the number of minutes that it takes these 200 people to fill out the form. And now they want to use that data to estimate how long the average person of all people in the population, instead of just in that sample, take to fill out the form. So once again, we need to start by just writing down the data that we have and the information that we have. In part A, X bar is the sample mean, which is 8.2 minutes is the average length of time that it takes the people who they surveyed to fill out the form. The standard deviation was 2.2 minutes. And the number of people in the sample was 200 people. All right. Part B now is asking to construct a 90% confidence interval for the population mean time to complete the forms. So we're using a wider confidence interval than the last problem, which asked for a 95% confidence interval. So remember that the confidence for 90% confidence interval is the point estimate plus or minus the error bound margin. So we know that our point estimate is 8.2 minutes plus or minus the error bound margin. The error bound margin, remember, is equal to z times standard deviation divided by the square root of m. So z will be different than it was in the last problem because we're using a 90% confidence interval. But if we look at that same chart, so I have to find the chart. You can see the confidence interval of 90%, 1.645 is the z-score. That could also be done using Google Sheets with the norm inverse function. But if we have a confidence interval that's not listed on the sheet, but since it's on the sheet, it's pretty easy to use that instead. So the error bound margin then equals 1.645 times 2.2 divided by the square root of 200. And that equals 0.26. We can take the 0.26, put it back into this formula, know that our 90% confidence interval is 8.2 plus or minus 0.26. Our 90% confidence interval is then 7.94 to 8.46. 8.2 minus 0.26 and 8.2 plus 0.26. Moving on to part C, which asks to explain what this confidence interval means. That means that we can be 90% certain that the true length of time takes, on average, for our population, which in this case would be the all U.S. citizens who fill out the census, is between 7.94 and 8.46 minutes. Moving on to part D. If the Bureau did another survey and kept the error bound the same and surveyed only 50 people instead of 200, what would happen to the level of confidence? So now, if we're surveying only 50 people here instead of 200, with this being on the denominator, the error bound margin, if it stayed the same, then we would have to make this z-score. If this is staying the same, but we're dividing by a smaller number, then we would have to make this z-score smaller as well. So the confidence interval would decrease, meaning we couldn't be we would have a smaller amount that we'd be certain of that the population, or that we'd be 90% certain that our population average would fall between. Finally, suppose the Bureau needed to be 98% confident. So now we're increasing the confidence level of the mean population length of time. Would the Bureau need to survey more people? Why or why not? This is just the opposite of that previous problem. So now if we're increasing this confidence level, we must need to also survey more people. So you need to increase this, the number on the denominator. So yes, if confidence interval increases, then we need to survey more people. Problem 3 is looking at the number of times that a BMA student calls their parents during a training camp. So instead of surveying all BMA students, they only surveyed 20. So that was our sample of 20 BMA students. From that sample, the mean was 7.9 and the standard deviation was 2.8. So we can go through here and fill out X bar is the sample mean. So that would be 7.9, standard deviation 2.8, and the sample size is 20. So if we want to, in B, construct a 90% confidence interval, that would be X bar plus or minus the error bound margin. And so we know that 7.9 plus or minus the error bound margin using that sample. The error bound margin, of course, is equal to z times standard deviation divided by square root of n. For our z-score, since we're looking at a 90% confidence interval, the alpha would be 0.1, and looking at that on our chart, 90% confidence interval, 1.645 is equal to z, 1.645 times 2.8 divided by the square root of 20. Which, if we calculate that out, is equal to 1.03. Looking at this, for part C, the confidence interval, explain what that means. Oh, sorry, we have not finished this one. Then we've calculated the error-bound margin, but we still need to know the confidence interval would be 7.9 plus or minus 1.03. So that means our 90% confidence interval is equal to 8.93 for and 6.87. Sorry, I've written those backwards. 6.87, 8.93 times. What does this confidence interval means? It means we can be 90% certain that the true number of times the average BMA student calls home is between 6.87 and 8.93 times. All right, moving on. Part D says define x and x bar. So x would be number times a BMA student calls home. X bar is the number of times, or the average number of times, sorry. Average number of times that the sample BMA students called home. And finally, in part E, what would happen to the error bound and confidence interval if 50 BMA students are surveyed? So now, if we're surveying 50 instead of 20 here, we're going to be dividing by a larger number, which means that the error bound margin will go down and our confidence interval will be the same.